In this video, we are starting a new unit called quadratic functions. This unit is very vocabulary heavy, so we need to make sure that we learn all of the vocab that you need to understand for the quadratic functions unit. So what we're going to start with today is called parts of a parabola. So what you see on this page and on your paper is this U shape. So if you were to graph this equation, whether you graphed it by plugging in numbers by hand or you graphed it by plugging it into a calculator like Desmos, what would happen is if you plugged in this equation right here, you would end up with this U-shape graph. So this U-shaped graph is called a parabola. So anytime you see the word parabola, it just means the U shape of this graph. So on a parabola, so let's write that down first. So the shape a quadratic equation makes is called a parabola. On a parabola, there's different parts that are very important. The first part I'm going to tell you is this one right here. You know this word. This ordered pair lives on the y-axis. So when an ordered pair lives on a y-axis, we call it the y-intercept. A y-intercept is where it touches the y-axis. What I know about this y-intercept is that it's an ordered pair where the number sits in the y spot. So the y spot of this ordered pair is the number 1, 2, 3. So I put that 3 in the y spot of the ordered pair. A y-intercept always has a 0 in the front. Okay, so that's called the y-intercept, very easy. The next word that we are going to learn is if this is called the y-intercept, if we look at our x-axis, it touches it twice. So this is the x-axis. My u touches the x. Here's the U shape. It touches the x-axis here, and it touches the x-axis here. Okay? So if a graph crosses the x-axis, we call those x-intercepts. Just like y-intercepts, but this time it crosses the x-axis. What I know about x-intercepts in this chapter is that there's 3 other very important words that we use for x-intercepts. The next word that x-intercepts are called, they're also called zeros. The reason why they're called zeros is because in their ordered pair, this one crosses at the number -1, and there's a 0 in the back. An x-intercept has the number in the x spot of the ordered pair. So there's one x-intercept at -1, the other x-intercept is at -3. These x's have a 0 in the back, so that's why they're called the zeros. Okay? So they're also called solutions. If you were to solve for x, that's the solution of your graph. So these are called solutions. That will make more sense in a couple of weeks. And then the last word we call them is roots. I kind of say this is kind of like a tree, and then everything here, it's like where the roots of the tree would start. I don't know why they're called roots. We just have to know. X-intercepts, zeros, solutions, and roots are the 4 most important words of this chapter. We're going to do a lot over the next couple of weeks that revolve around these 2 spots right here, the x-intercepts. Very easy. The next word is this word at the very bottom of this graph. This shape kind of looks like a V. It looks more like a U, but kind of like a V. So the very bottom of the graph is called the vertex. We get to the vertex by going left 2 and down 1. So my vertex is the ordered pair that's the lowest part of this graph. Because this vertex is at the very bottom, we also call this a minimum. In just a minute, we'll talk about minimums and maximums. But for right now, our vertex is our minimum. Okay? The last word that we have here is, let me go as a different color. Here we go. So this line that cuts right down the middle of this graph, if you were to look at a graph, this is called symmetrical. So everything that's on the left side is also on the right side. So this line that goes right down the middle of the graph is called the axis, I make the X big on purpose, of symmetry. We'll use this a lot too. Axis of symmetry is written as X equals, and then my X right down the middle of this graph is the number -2. So my axis of symmetry is always X equals. Hence, I made the X big, so we remember axis of symmetry gets written as X equals. So it's X equals -2. Okay, so those are all of the parts of the parabola. To refresh, we had a y-intercept, that's where it crossed the y. We have x-intercept, that's where it crosses the x. We have a vertex, that's the bottom of my graph. And then I have an axis of symmetry, which is a line that cuts down the middle of this graph. Okay, so make sure you have all of those written down for me, please. So now we're going to get a little bit more specific on a couple of these pieces. Let's not do it. Here we go. We'll just scroll. Okay, so maximums and minimums. So every parabola, like we just said, has a maximum or a minimum point. So if I look at this graph right here, there's a dot at the bottom. If there's a dot at the bottom of the graph, then it's a minimum. And the way that we label it is the minimum. What is the lowest point? The minimum is -3. So this graph has a minimum point. The lowest point is at the number -3. Okay? So now we're going to talk about graphs that are positive or graphs that are negative. So positive graphs open up. See how these arrows? I like to be silly and say positive graphs if I like turn this into a little smiley face. Whee! This is a little smiley dude. He's happy. So he's a positive graph because it's opening up. My little happy graph. The way that I could always know from the equation is if this front number is a positive number, that's called the A value, just like in the last chapter, A, B, C. So if I look at my A, my number in front is a positive number, so therefore my graph is going to open up. Okay, so positive graphs open up. Super easy. If it's positive, then we're going to have a number at the bottom. We said that that was the lowest point, so that's the minimum, and it has a minimum at the number -3. Pretty easy. Okay, let's move to the next piece. So now this graph, let's move this over here. This graph has a point at the top of its graph. So this one is opening downward. So this has a maximum. It has a maximum. The highest number on this graph is 4. So this graph has a maximum at 4. So now, is this graph positive or negative? We can keep that there, sorry, max 4. So to know if a graph is positive or negative, to be silly, I turn it into a little face. This guy is a sad face. He's negative. He's not a happy graph because it's opening downward. So negative graphs open down. The way that I know that is if this front number is a negative graph will always open downward. So this graph is negative. So in a minute, it's going to ask, here's a picture. Is it positive or negative? This one is negative because it's opening down. This negative graph has a maximum point at the number 4. The highest point on this graph is a 4. Okay, so this has a max at 4. Okay, moving on. Next piece. So this takes us back to what we learned at the very beginning of the year. So in this type of graph, domain and range, it's been a long time. What do we know about domain and range? Domain is always the x. Domain goes from the left side of the graph to the right side. Here is the furthest left spot on that graph. That's an arrow. Here's the furthest right spot on this graph. Also an arrow. So what this means is this graph is going to continue going forever towards the left and forever towards the right. So when a test asks you, what is the domain of this quadratic graph, the answer is always going to be all real numbers. Even if there are no arrows, this graph will always go forever to the left and forever to the right. Okay? So domain of a U-shaped graph is always going to be all real numbers. Next, range. So what we know about range, when we learned it way back in like September, range is the Y. Range is talking about the bottom of the graph to the top of the graph. Okay? So if we look at this one, when we do range, all we need to notice is my maximum or my minimum point. So here's the highest point on the graph. That number is 3. This graph is opening down, so I'm going to use this symbol. So when we're looking at range, we just look at our maximum or minimum point. So this one here, the highest point, the only point on this graph that's the very highest, is the number 3. This is opening downward. That means all of my Y values live less than or equal to the number 3. We do the same thing here. Here's my minimum point. That number is -4. All of my Y values, this is opening up, so therefore my Y values are all greater than or equal to the number -4. Okay, so if that's tricky for you, it's okay. We'll keep working through it. Domain is always going to be all real numbers. Range is always Y. You find your max or your min. If it's opening up, it means it's the greater than sign. If it's opening down, it means it's the less than sign. Not too bad. Okay, so from here, it's now your turn to practice. I'm going to do number 1 with you so you know how to write these things, and then you're going to get all the way through number 12. Okay, so in number 1, here we go. Let's look at this together. This is also in your Go Formative and in your packet. So does this graph have a maximum or a minimum? This graph has a maximum because it's the point at the top. The maximum number of this graph is 1, 2, 3, 4. This graph is a negative graph because it's opening down. If I made this guy a little smiley face, he's sad. Aquí es negativo. This is a negative graph. Okay? Axis of symmetry. Axis of symmetry is the invisible line. There's an X in it. So axis of symmetry is always going to be written as X equals. We know axis of symmetry is an X equals. The symmetry, the line that crosses right down the middle of this graph, crosses through the x-axis at the number -2. It went left 2. So my axis of symmetry, my line that cuts down the middle, is x equals -2. My vertex is the point at the very top or the very bottom. Here it is. A vertex is written as an ordered pair. To get to this point, I need to go left 2 and up 1, 2, 3, 4. Left 2 and up 4. Vertex. My zeros, remember the words zeros. Sorry. Here we go. The words zeros, roots, and solutions, and x-intercepts are all the same. All these words mean is it's the place where it crosses the x. It's the most important word on this graph. So my zeros, where they cross the x-axis, it crosses at 1, 2, 3, 4. -4 and a 0. I'm going to put a 0 in the back. This one here crosses at the origin. That's 0, 0. Okay? You can write them as ordered pairs. Sometimes on a test, it would say this. There's 1 0 at -4, and there's 1 at 0. So for today, let's write them as ordered pairs. But as we move through this unit, I'm going to switch over to writing them like this so you can see it in both ways. Domain, we just said domain is always all real numbers. The reason why, the left side of the graph goes forever to the left. The right side goes forever towards the right. This domain is all real numbers. What I know about range is that range is y. My range is just my maximum number. So it started at 4, and then this graph is everything below that number. Okay, so my range, it starts at the number 4. Your range number will always match this number right here. So it's my y value. It starts at 4 and it's facing downward. So it's everything below that. Okay, so you're going to continue on, keep going through number 2, blah, 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 blah. Know that this is going to be written as x equals. Your vertex is going to be written as an ordered pair. Your zeros will be written as zeros. Your domain is always and your range is written like this. Y is either less than or greater than your number from the top. Okay, so work through these. If you have questions, talk to your teacher. And this is the majority of the chapter. If you get good at this vocab, this whole chapter will be really easy for you.